Chinese story of a blind man and an elephant. Once upon a time, there was 6 men, each of whom touched a different part of an elephant, unable to see what their hands were resting on. Asking to the describer what they have touched, the man who felt the sight of the elephant said, "I touched a wall," and the man who felt the elephant's tusk said, "I touched a spear." The 6 men argued among themselves, was it a snake, a cow, a piece of rope? Only when they worked together, sharing their different ideas and experience, were they able to discover the truth. Well, it seemed as if scientists across the world were increasingly getting the point of the story. They were expanding their communication across fields, telling one another about the part of the elephant. The result is the formation of the new interdisciplinary scientific fields. They are painting expanding picture of the world around us. Today, we will give you a brief introduction on overview of doing interdisciplinary research. What is interdisciplinary research? According to the definition of interdisciplinary research, is a process of answering a question, solving a problem, or addressing a topic that is too broad or complex to deal with adequately by a single discipline or profession. Interdisciplinary involves integration across interdisciplinary theories or methods. For example, bioinformatics is an interdisciplinary research that applies computer science to biological problems. Interdisciplinary research has been gaining traction in the recent years and has been creating a wide social and economic impact. Since the mid-1980s, research papers have increasingly cited work outside their own disciplines. The analysis shown here, the fraction of papers referenced that point to work in other disciplines is increasing in both the natural and the social science. The fraction that point to another specialty in the same discipline show a slight decline. With research now become increasingly global and collaborative, interdisciplinary research is deemed to be the future of science and research. How to do interdisciplinary research? Take my research field bioinformatics, for example. I would like to give you some suggestions. The exploration of data from high-throughput biological experiments like sequencing and microarrays have led to the science called bioinformatics. Bioinformatics is an interdisciplinary field that develops and applies computational methods to analyze large collections of biological data, such as genomic sequences, cell populations, or protein samples, to make new predictions or discover new biology. The computational methods used in bioinformatics include analytical methods, mathematical models, and simulation. In order to do research in bioinformatics, you can follow following steps. Ask the questions, get the relevant disciplinary insights, answer the questions, comparing and contrasting results from previous methods. The process of interdisciplinary research must start by asking an interdisciplinary question. This may seem a simple step, yet one cannot know if a question can be answered well within one discipline unless one has an understanding of the strengths and the weaknesses of the different disciplines. Biology provides a huge amount of different computational problems, which require computational approaches to solve. Almost every area of biology has a corresponding subfield of bioinformatics, i.e. genome sequencing and analysis, gene function predictions, protein identifications, and function annotations. We can ask a question by meeting with biologists and computer scientists. Given a common problem, the two groupers will ask different questions, pick up on different details, use different ways to describe the problem, and come into the situation with different assumptions. The biologist gathering knowledge will often describe his or her work as if telling a story, strives to draw conclusions, and construct models. Compare this to the logical and precision-oriented computer scientist. Their goal are using the rules and designing optimal method to solve the problems. You may have no chance to discuss with biologists or computer scientists face-to-face. Then the best way is to read academic papers. Following is important journals and conference on bioinformatics. You can download an academic paper from internet. Let's read this paper downloaded from journal Genome Research. The title of the paper tells us its aim is to design a computational algorithm to de novo assemble short reads. The short reads is also called short DNA segments. The algorithm used a technique called de Bruijn graph. We can find the question of the authors from the beginning of the introduction section. As the highlighted text shows, the biologist question is how to assemble the short reads generated by next-generation sequencing techniques without no reference genome. The question is proposed at some real application background, i.e., determining the genome sequence of new species. Given the same question, the computer scientist considers the short reads as nodes and connect two nodes with edge if one short read overlaps another. Thus, they construct a de Bruijn graph according to the short reads and the overlap. The goal of the computer scientist is to design the strategy that can find the longest path from the graph. After getting the question that should be solved, the next step must involve the gathering the relevant discipline insights. We can do this from two perspectives. One is to reflect on the nature of different disciplines and identify those that are likely to have something to say about the issue of concern. Take the paper I mentioned above for example. What the biologist concerned is the assembling of short gun reads, or piecing together fragments randomly extracted from the sample to form a set of contiguous. What computer scientists concerned is the problem of short reads, high rate repeats, and natural repeats when constructing the de Bruijn graph. The second perspective is to ask what phenomena, theories, or method are implicated, and then what kind of method or theories have been used in previous research in each discipline. Moreover, we should survey the advantage and disadvantage of previous methods and be careful to those ignored theories and methods of different disciplines that may shed light on the question. Generally, the author will introduce this in introduction section of the paper. We also can perform a detailed literature survey so as to identify the theories, methods, and the phenomena encompassed by previous research. Take the paper I mentioned above for example again. The highlighted text shows previous biology sequence technology such as Sanger method produce long reads, while the new sequencing technology produces short reads. On the other hand, computer scientists have designed a de Bruijn graph based on methods such as OLA to assemble short reads. However, these kind of methods represent the nodes in the graph based on K-nucleotides or K-mers, not reads. This way may easily deal with the race repeat problem, but can only be used for assembling short reads with no very short sides, which motivated the authors to design a novel method called well-weight to fill in the gap. After you know the question from different discipline angles, the next step is to design an efficient way to solve it. In method section of the paper, the authors will figure out the detailed procedure of the short-read assembly. This also is the main innovation of the paper. Informatics researchers in computer science field, you should focus on this section. You are required to have a strong programming background, some background in math, statistics, and a background in biology. In order to prove the efficiency of your method, you should compare your method with other existing methods under the same condition. Usually, for fair comparison, your method as well as comparing method should be implemented on the same dataset. Firstly, you should grab some data from public database or supplementary of published papers. Sometimes there are no golden benchmark dataset. You can computationally simulate some dataset. In this paper, the authors take the method on both experiment dataset and the simulated dataset. The experiment data was downloaded from public website, and the simulated dataset was generated by sampling DNA sequence from 4 different species. After that, you should build an evaluation matrix. In order to quantitatively evaluate the performance of each method, some statistical measures are adopted, i.e. precision, recall, and F-measure. Precision measures the percentage of predicted ones that match the known ones according to benchmark dataset. Recall measures the fraction of known ones that are matched by the predicted ones among all the known ones. F-measure is the harmonic means of precision and recall. There are also some spatial evaluation measures for some special applications. In this paper, N50 and coverage are employed to assess the performance of measures. N50 refers to the longest size of the assembled contiguous, and the coverage refers to the degree that reference genome or contiguous are covered by contiguous or reference genomes. The results are listed in table or figures for easy comparing. Since the benchmark dataset is incomplete, sometimes the results predicted by computational methods did not located in benchmark dataset. They may be ignored by previous researchers. The authors can list them out and perform a detailed literature survey and develop a more comprehensive analysis. Your analysis provides guidance for biologists. Well, in this section, I take my research field by informatics for example, give you some guidance for how to do interdisciplinary research. Hopefully, it is helpful to you. Thank you for your listening.